itinerary of what we're going to learn and everything else that you need to work with here. All the code that we're going to be working with is located in this simple storage link that we can go ahead and click. It's in its own different repository. We can go ahead and click the file to see all the code that we're going to be working with. So let's jump into it. Additionally, back in our full blockchain Solidity course, right at the top, there's this resources for this course section. If you have questions, engaging in GitHub discussions, Stack Exchange Ethereum, and Stack Overflow are going to be great places to get help and get support. I highly recommend making a Stack Overflow, Stack Exchange Ethereum, and a GitHub account so you can participate and engage with the community. Welcome to the Remix IDE, or the Remix Integrated Development Environment. This is going to be where we're starting to teach you how to work with Solidity and work with smart contracts and deploy to blockchains. We're going to use Remix to get us up to speed, as it has a lot of nice features that allow us to really see and interact with blockchains and really see what's going on. But eventually, we're actually going to move off of Remix to another platform. But all the Solidity that we're going to learn here obviously is going to apply everywhere as well. When you come to Remix, there's a whole lot of different plugins like Solidity, Learn ETH, Solhint Linter, and a whole bunch of other plugins as well. I'm going to go ahead and start by clicking the Solidity plugin, but we're not going to use any of these plugins for now, but later on you can kind of go back and learn a little bit more about what these plugins do. So let's start perusing. Let's start coding some things. On the left-hand side over here is where we're going to interact with everything. So let's go ahead and click the files up here. Now you can always go back and peruse this a little bit more. And in fact, I highly encourage you to, because that's how you're going to learn the most, the quickest. But for us, we're actually just going to go ahead and start with our own brand new file. We're going to create a little application that can store information on the blockchain for us. And this is our first project that we're going to do in Solidity. So we're actually going to create a new file, and we're going to call it simple storage.sol. All Solidity has an extension of .sol at the end. It stands for Solidity. Now let's take inventory of what we're going to be working with here. This is the Solidity compiler tab. It compiles all the Solidity code down to machine understandable code, or machine language here. There's a whole bunch of different parameters we can choose when working with Solidity. We can choose the compiler version, we can choose the language, which we're only going to be working with Solidity, the EVM version, don't worry about this for now. So let's code our first Solidity contract here. Now we are going to use something a little bit special here. When we actually deploy these, we're going to use a JavaScript virtual machine. So we're going to use a virtual machine that's going to simulate actually deploying to a testnet or a real network. We're not actually going to deploy on a real network. We will in a little bit. But just to get started, we're going to work with a JavaScript VM, which is kind of a fake environment for now, okay? Testing locally and understanding how to test locally will make your coding experience a lot faster. As you saw, when we sent some transactions, some of them actually took a lot of time to actually deploy. We don't want to have to spend that much time waiting around for our tests to actually finish. So we're going to use a JavaScript VM to kind of dummy it for now. But let's just start coding and go from there. So the first thing that you're going to need in any Solidity program is the Solidity version. So that's always going to be at the top of your Solidity code. It's defined by doing pragma, Solidity, and the version. We're going to be using some version between 0.6.0 and 0.9.0. So we're saying we want to use anything between 0.6 and 0.9. And as a force of habit, I just automatically hit Command S whenever I write anything. So that's why you saw some of this pop up here. Hitting Command S or Control S, depending on if you're Windows or not, we'll hit this compile button and we'll compile everything for us. Now, if we want a specific version of Solidity, we can also do 0.6.0. And if I go ahead and hit Command S or compile, our compiler will automatically revert to 0.6.0. However, if I try to do 0.8.0 with my Solidity at 0.6.0, it's going to give us an error. It's going to say the source file requires a different compiler version. We're using 0.8.0 and this is 0.6.0. So we're going to go ahead and hit compile and it's going to automatically move down to 0.6.0. We can also do caret 0.6.0, and this will allow us to work with really any version of 0.6. It'll work all the way up to 0.7, where if we hit Command S or Control S there, it'll give us an error. So this only works with any version below 0.7 and above 0.6. We're going to be using version 0.6.6. However, in future contracts that we work with, we're actually going to work with different versions of Solidity. The reason we're going to be changing versions throughout this course is that Solidity is a constantly updating language. Being good at switching between versions is going to make you an incredibly powerful smart contract engineer. The next thing that we're going to do is we're going to define our contract. So contract is a key word in Solidity, which stands for our smart contract that we're going to create. You can think of a contract similar to a class in Java or any other object-oriented programming language. So we're going to give our contract a name here. We're going to call it simple storage. And we're going to add this little curly bracket to say this is the contents of our contract simple storage. And I went ahead and hit Command S, and we can see it is compiling successfully. You could hypothetically deploy this right now, and this would be a valid contract. So great job for making it this far. Now in Solidity, there are many different types that we can work with. Let's go into some of the types of Solidity. We can have integers, aka whole numbers. They can be uint, as in an unsigned integer, meaning they're not positive or negative. We can also have an int, and we would define a variable by doing uint 256 favorite number equals 5. So we have an unsigned integer. Uint 256 means this is an integer of size 256 bits. So we can have this number be up to 256. You can also do uint favorite number equals 5, but if you want to be a little bit more precise, a lot of protocols and a lot of smart contracts will do the whole name like uint 256. We can also have booleans. Booleans are true, false. So we can have boolean favorite bool equals true. So this favorite bool would be true. It could also be false. We can have strings. String favorite string equals string. A string is a string of text here, right? It's going to be some word or phrase or really any of these keystrokes here. Similar to the unsigned integer, we can have an int 256. Favorite int equals -5. So it could be positive or negative. We can have an address, which is going to be some type of Ethereum address. So we could do address, favorite address equals, and then we can even copy right from our MetaMask and just paste it right in here. This is going to be a valid address here. You'll also notice that we end all of our statements with a semicolon. We can have a bytes object, size 32 bits, favorite bytes. For our example, we're just going to use the word cat because cat is a string which can be converted down into a bytes object. Byte 32 means that there's 32 bytes in this variable favorite bytes. We can also do bytes 2, bytes 3, bytes 5, etc. with a maximum size of bytes 32. For example, we can't do bytes 64. We're going to be talking about some other variables as well, like arrays and mappings, but let's just stick here for now. If you want to learn more about the different types and the different variables that you can use, head over to the Solidity documentation, and there's a link in the GitHub and the description to show you this section. For now, for our simple storage, let's say we only want to store numbers. We don't want to store anything else. So we're just going to go ahead and delete everything and just have uint 256 favorite number at the top. Now in Solidity, if I do this, favorite number actually does get initialized even though I didn't have it initialized to 5. If I leave it blank, it gets initialized to the null value. In this case, it would be initialized to 0. So for now, let's just not initialize it to anything. That way it'll get automatically initialized to 0. This means that when we deploy this contract, as of right now, favorite number will start off as 0. If you get confused, you can also make a comment on this. You could say, this will get initialized to 0. This double slash here is the way to make comments in Solidity, and it won't get executed as code. So we can write whatever we want as long as it's preceded by 2 backslashes. Now let's go ahead and create our first function. Functions or methods are self-contained modules that will execute some task for us. And in Solidity, it's the exact same thing. They're defined by the keyword function. Let's make a function called store that will change the value of this favorite number here. So we're going to call store, and we're going to allow it to be passed a variable. So we're going to allow it to be passed a variable of type unsigned integer 256, and we're going to call it underscore favorite number. We're going to make this a public function, which we'll get to in a minute. And all we're going to do is we're going to set favorite number equals to whatever variable we passed in, favorite number. So this, in its simplest form, is how you can define a function. Now, just to visualize what we're working on so far, let's go ahead and deploy this contract so we can actually start to interact with it. So if we hit this button, this will bring us to the Deploy tab and will allow us to deploy our smart contract here. Using our JavaScript VM, it's given us a fake account with some Ethereum in it. It has 100 Ethereum in it to start. And same as before, anytime we want to interact with the blockchain, we have to pay a little bit of gas, even in our fake virtual machine here. And we want to simulate that. So you'll see it has some of the same parameters here as making a transaction, like gas limit, for example. When we deploy a contract, it's going to cost a little bit of Ethereum or a little bit of gas to do so. So let's go ahead and hit this deploy button and see what happens. So once we deployed with this virtual machine, a few things happened. We have Remix kicking out this section down here saying, great job, you've deployed something. And if we scroll down, it says transactions recorded 1. We can look at all the transactions we recorded, and we can see it says deployed contracts, and we have a contract here that we've deployed. Now let's zoom out just a hair here so we can see everything a little bit better. In this simple storage contract, we see this big store button because there's one public function that we can actually interact with. So we can add this number here and we'll hit store, and you'll see again, we have a completed transaction. And if we look at our contract, we'll have paid a little bit more gas, right? We'll have paid a little bit more to interact with this function because again, anytime we want to make a state change on the blockchain, we have to pay a little bit of gas. The reason MetaMask isn't popping up is because we're kind of doing it in this simulated environment. So this is great. However, it looks like we can't actually see what our favorite number is. We can't actually look at it. So how do we actually make sure that we can view this favorite number? Well, let's add another parameter to this as well. If we add public to our favorite number, we recompile by hitting Command S or hit the compile button. We delete this contract and we redeploy and scroll down. Now we'll see two buttons pop up. This blue button to show us favorite number, which again is initialized to 0, and we have this store function. So let's talk a little bit about why this public variable allowed us to see this new button, this new favorite number button. This public keyword defines the visibility of the variable or the function. There are currently 4 different types of what's called visibility in Solidity. There's external, public, internal, and private. We're mostly going to be working with public for now, but it's important to note how the rest of these work. Public functions can be called by anybody, including variables. So oddly enough, variables are a function call to just look at them and return whatever that variable is. An external function means it can't be called by the same contract. It has to be called by an external contract. So if in this contract, I had this be external, I couldn't call the store function. I couldn't call the store function inside this function because the function is external. It means somebody outside of the contract has to call this function. Internal functions, however, can only be called by other functions inside of this contract or in its derived contract. And then private is the most restrictive, as private functions and state variables are only visible for the contract they are defined in and not derived contracts. Now, the reason that we didn't see favorite number show up in our original contract deployment is that if we don't give a state variable a visibility, it will automatically get set to internal. So if we want other people to be able to read it, we have to change it to public. Now, let's see how this interaction actually works. If we hit the favorite number button right now, we'll get this